We may not see the other part, but I'll record that. Okay, we'll go from current slide. And it's not from current slide. It's from this slide. Okay. Now, why? Let's try something here. Who wants to be the recorder? Okay, someone record, put it on the board. I'll record on here too, so that for people at home can view it too. Okay, or you can go back and look at it. Anyone want to write on the board? Please, somebody. I know you're all not shy. Somebody's bold. Okay, come on. And you can't have worse handwriting than me, so give that up. Okay. Saya came in. I didn't mark him yet. Anyone else come in since I called roll? Come on, somebody. Right on the board. Okay, good. Can you catch? Good deal. Thank you. All right.
It's not operating.
That's not.
Nope.
Okay.
Not too short to mess with your.
What?
Too short to mess with your projector.
Okay. Yeah, I never use this because I'm
Batteries are slow.
calling now. Okay. What you want to switch?
Source search.
Which one?
Source search on blue button.
This one right here?
Yes.
Oh, maybe that's it.
Connection. Hit enter.
Signal status is lost. Huh?
Yeah, hit enter to change.
Which one?
Enter.
This one?
Wait.
Or this one?
That one. That one. That's enter. You gotta go back to where you were.
Okay.
Hit source. Go. Computer 1.
I
Now
didn't do
hit
anything.
enter.
There we go.
Give a minute to see if this works.
Thanks for your effort. I think we'll just go like this. It's probably screwed something up bad.
Yeah.
All right. Tell Bree what she needs to do here. Okay, let me catch up with her. Let me see if my pen works. I think it does. Okay. All right. We factored out a 4y, right? And what's left? 6x squared minus 19x plus 10. Okay. Got it? Okay. And we brought down the 4y. And to do the factoring of this, what we're going to do, we determined the AC. What was AC again? 60. And what was B? Negative 19. Now that's where we stopped. Okay? I mean, not pull my... Okay, I'll be doing this from now on. Okay. What we want to investigate that. We need two factors to be 60 that add to be negative 19. What does it tell you about those two factors? They multiply to be a positive number and add to be a negative number. What must they be? Multiply to be positive, what does that tell you? Same signs, and to add to be negative, they both must be negative. So let's start our trial there with minus minus, okay? Leave a space after it, minus minus, okay? Now, what? First factor, simplest, 1 and 60. What does that add to? Minus 61, not minus 19, okay? Next, negative 2, negative 30. Oh, I'm sorry. All right, no, okay. Yeah, I'm sorry.
Under 63.
Yeah, over here.
We're factoring the...
Two factors here, minus 1 and minus, this is running out fast. Okay. All right. Minus 1 and minus 60, those add to be minus 61, not minus 19. So do the next one, minus 2 and minus what? Minus 2 and? Multiply to be 60. Negative 2 and negative? 30. And they add to be? Negative 32. Closer, but still no cigars. Next one. Negative 3 and negative what? 20. Those add to be negative 23. Closer, but still not. Next. Negative 4 and negative. Say 15. Ding, 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 ding. That's negative 19, isn't it? All right. We stop there. We don't have to do any more. We found our combination. So what we're right here is underneath there is 6x squared. Keep the 4y. 6x squared minus 4x minus 15x. See, those add to be minus 19x, right? Okay? And then the plus 10. Now what do we do? Keep the 4y. Don't forget that. What do we do inside there? Say again? Group. Group the first two and the last two. Now, I had to include the sign in that second grouping. Okay? All right. Have parentheses here and then the parentheses in front of the minus sign. Yeah. That's it. Excellent. Okay? Now, what do we look for in the first group? Common factors. And what is it? 2x. What's left? 3x minus what? 2. Excellent. And the second group? Second? Take the sign with it. Minus 5. And what's left? 3x. Say again? Minus 2. Ding, ding, ding. We've got it. Okay? Now what? Keep the 4y. Bring that down. And what do you notice here? We have a common factor. 3x plus minus 2, right? Pull it out. 3x minus 2. And what's left? 2x minus 5. Perfect. We have just factored it. Okay? Does everybody see how that works? I'm going to go and turn this off since it's not doing any good whatsoever. Okay? And, all right. Any questions on that? Does that make sense? Okay? Now, there is a check your, and by the way, the book has 4y times 3x minus 2 times, there you go. Oh, sorry, that doesn't throw well, does it? Okay, 2x minus 5, and that's exactly what they got. Right after that is a check your understanding 7, and does anyone need to see that, or you feel like that's something you need to do on your own? On your own? Okay. And then there's objective 11.3 practice problems, 5 of those, a big 5 again, so please do those 5. And that's all from 11.3B. That's all she has. But I can, well, for those who are not here, okay, or when you're viewing this at home, let me just show you the slides here. You can't see them, but for people who are at home. First, factor out, let's just review. Factor out the 4y. You get 6x squared minus 19x plus 10. Then we do the AC method. AC is 60. 6 times 10 is 60. And the B, and oh boy, they jump right to, and here's the factorization, minus 4 and minus 15. Wow, that wasn't very helpful, okay? And so they split them up just like we did. They grouped them. Now, when they did their grouping, this is an idea, and let me, oh yeah, do you take notes? Oh, okay. Yeah. Right. Let me show you what they did on their grouping. If you like this better, you certainly can. It's no different to me. But when they do in fact, go on and turn on the second light, second switch, because there's no projection anymore. Okay, when they got to this point of 6x squared minus 4x, that was it, right? Yeah. And then they had minus 15x plus 10. That's right, right? We were there. Okay, what we did, we just grouped this, these two, and those two, and then remembered to pull the sign out. Here's what they did. They grouped these two and put it 6x squared. That probably is not going to show too well. Okay. 6x squared minus 4x. Okay. Then what they did is pull out the minus sign first, and what's left here? 15x. But if you pull out the minus sign, this becomes a minus 10. Okay. If you like that better, the book does it that way, certainly fine. I just included the minus sign in the second grouping and then factored out the minus sign, and then you got the minus 2. So whichever way you prefer. All right, good, thanks. All right, then they factored just like we did. And what they did, they left off their 4y, okay? In the show here. I just wanted to remind you of that. I didn't notice it when they went to a new page. They, in fact, they did it much earlier. They just left it out, and then they're going to go back and put it back in. I suggest you carry it with you. Otherwise, I forget to go back and put it in. Okay? And they got the quadratic to be 3x minus 2 times 2x minus 5. Then they went and put it back in the 4y. No. They put the 4y and went back to the other and then put the factorization. Boy, weird way to do it, but it's fine. It works. And if you prefer that, go for it. Okay, I'm talking mostly to anyone watching this at home because you can't see what I'm talking about. Okay, before I go to 11.4A, I have a special treat for you, okay, because y'all are so special. And that is the second quiz. It covers through from 11.1 to 11.3. And now that we finished 11.3, I wanted to make sure you get your quiz before I give it to you. Okay, keep 1 and pass 2. 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 I'll pass through. I got you. Keep 1 pass 1. Keep 1. Is anyone sitting behind you here? All right. I'll put 1 on you there. All right. Okay. So let's now go to 4A. Okay. And by the way, you have at least a week to work on this. Most of you will probably get it in sooner. But if you have questions, ask on Monday and then get it in on Wednesday if you can. You can have more time if you need it. But look, the second test is coming up pretty soon, so don't put it off. Try working on it as much as you can this weekend. All right. We're going to 11.4A. Special factoring. Would you rather write on this board or? Okay. That way you might be able to see what I'm doing here. And that. Oh, you got that. Okay, good. Okay. All right. So let me get slideshow set up. This takes so much wasted time. Okay. Factoring polynomials, module 11. Still got that. Now we're going to 11.4. Special factoring. All factoring is special, isn't it? Okay, 11.4A, factor the difference of two squares and the perfect square trinomials. Okay? Now this is just basically a review of what we did in the last chapter, on the last test, in 10. we looked at something like this, okay? You can't see this, but if you write the a plus b times a minus b, but don't write the answer, okay? Okay? Review time. How does that multiply? Anyone remember? FOIL it, okay? FOIL it. Go for it. Tell her what to do. A times A is A squared. Okay. Next. A times B, the middles or the outers? Innards or outers? Outers, okay. A times a minus B then. And that would be a minus AB. And then the innards are positive AB. And then the last are, second, negative B squared. Exactly. Now what do you notice about that? The middles who add to 0. They disappear. So you're left with A squared minus B squared. Right? Guess what? Every time. We call these conjugates of each other. The first are identical. The second differ only by the sign. A plus B times A minus B. 4 plus 2M, 4 minus 2M. You know, you're multiplying two things together. The first are the same, the seconds are opposite. And this will happen every time you get the difference of their squares. Every time. Every time. So guess what? If you ever see a difference of two perfect squares, what can you do? Undo this. Immediately factor them as A plus B times A minus B. Do you see? Because this is always true. That A plus B times A minus B is always, go and write down, A squared minus B squared. Then anytime you see anything that looks like this, automatically factor it into this. Put your factor signs down there, your two binomials, and take the square root of this one, plus the square root of that one, times the square root of this one, minus the square root of that. Every time. You know how to factor right off the top. If you see the difference of two perfect squares. Now, the good thing to do is recognize your perfect squares. Okay? And sometimes I'll do, I'll go and do this for a moment. Okay? I like to write down, say, a bunch of numbers. 0, I don't really need 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I don't want to go much past that. Okay, let's call this n. Okay? Okay. What would then be n squared? 0. That was just fun. This one? 1. That was just fun. 4. 9. 16. 25. You want to write the rest of them? Okay. 25. 36. 49. 64. 81. 100. Okay, does anyone know 11 squared? 121. Excellent. And 12 squared? 144. You might know some more. Fine. Write as many as you want to. Okay? But recognize these as your perfect squares. If you recognize those as perfect squares, and you ever see that as a coefficient here or here, then you know, hey, this may be a perfect square polynomial. Binomial. Okay? But a difference of two perfect squares. Sorry. Gave you the wrong name. All right. So that expression, the a squared minus b squared, is called the difference of two squares. And the pattern just mentioned suggests the following rule. And if you want to write the rule, you can. But most of you have books or e-books or something to look at? Okay. You don't have to write it. It's on top of page 17 in module 11. And rule for factoring the difference of two perfect squares. Okay? Two squares. A squared minus b squared, it's just a plus b times a minus b. So let's do a couple of examples of that for those who don't have it, but just write down. X squared minus 4. Do that. I could do that if you want me to. X squared minus 4. Okay? Is that a difference of two perfect squares? You get it right as nice as you can. Yay or nay? Yes, it is. This is the square of x, and that's the square of 2. Can you write down the answer, or do I need to take it another step? Say again? I heard it 2. Say again? X minus 2 times x plus 2. Excellent. Okay? Now wait, I thought it was x plus times x minus. It doesn't matter. The order doesn't matter in multiplication because multiplication is commutative. Doesn't matter what order. Okay? How about y squared minus 9? Can you factor that? Yes. Y minus 3 times y plus 3, and the order doesn't matter. What's that? What? What's that? Okay, you want me to ask a lot of those? Okay. In class. Oh, no, I'm just kidding. Okay. All right. How about this one? Oh, really? Okay. Let's try it. A plus B. Oh, wait. No, if I do that one, it's going to give me this answer. Oh, A plus B times A plus B. Let's foil it and see. A squared help me. Plus AB plus AB plus B squared. These two go to 0? No, they don't. So no, that doesn't work. Doesn't work at all. Okay? The A plus B, these add to 2. A, B. So that's not, and guess what? Not factorable. Ever. Difference of two perfect squares? Yes, every time. Sum of two perfect squares? Never. Never factorable. Okay? And there's one that you can't put not factorable, and it doesn't just mean you can't factor it, it means it can't be factored. Okay. So that's not factorable over any integer. There are some numbers that can, but we won't get into those now. So let's do the focus. Okay? 16 x squared minus, yeah, you erase all that, minus y squared. Okay? I'll let her write it while I'm getting my pen found again. Okay. Okay, 16x squared minus y squared. Okay. Is that factorable? Let me see, I'm going to erase that. Help me. Is it factorable? Say again? Okay, I heard something, but I couldn't make it out. Say that again. 4. 4x. Feel like a dentist here, okay? Pulling teeth. Next. Second. Minus y. Okay. Next. 4x plus y. Perfect. All right. Got it. You see? Difference of two perfect squares. 16 is a perfect square of 4. X squared is a perfect square of x. So that's be 4x and 4x. And the y squared is a perfect square of y. So 4x minus y times 4x plus y. Perfect. Perfect. Okay? Boy, they skipped a couple. Okay, let me do this one. This is not in the, well, it's in the book, but yeah. This one, 4x squared plus 81. What would that be? What would that be? Say again? Okay, did I hear a 2x? Plus 9 times 2x plus 9. Okay. Not too long a memory, is there? Huh? What's wrong with that picture? Can't be factored because it's a sum of two perfect squares, never factorable. Only the difference of two perfect squares are factorable. Okay? So that one's not factorable. You've always wanted to write it down, but now you get a chance. Okay? How about this one? 4x squared minus 81. Yes. What? Yeah, you should.
No, that one's factorable because it's a negative.
That's a difference. So that would be your 2x minus 9 times 2x plus 9. Yes, that one is a difference of two perfect squares, so you can factor it. Okay, that's the difference, is the difference. Yeah, not the sum. Okay, got it. Okay, I'm sorry they skipped one, and here it is. 8x cubed minus 18x. What do you do with that? What's that? They're not perfect squares, are they? So we give up, right?
No.
Sounds like a winner to me. No. Okay.
You're going to have to take out a 2x.
Oh, yeah, you can factor out a 2x out of both terms because we always look for our greatest common factors. And what do you have left in the first one? 4x squared minus 9. Now that's looking a little bit more like a difference of two perfect squares. What would that be? 2x times? Okay, say it again. 2x. A little louder. Minus 3 times 2x plus 3. Excellent. You got it. Way to go. That is factorable. Okay? All right. How about this one? X squared minus 10. Okay, I heard an X. What you think, folks? Please tell me you think. Okay. Guess what? Well, 10 is not a perfect square. Remember, with difference of two perfect squares, x squared is a perfect square, but 10 is not. So that's not factorable using integers. Okay? Now, if somebody was really wanting to trip me up, they might say, yeah, but 10 is the perfect square of square root of 10. You would be absolutely right. You could write it as x minus the square root of 10 times x plus the square root of 10, but we aren't doing that. We're not getting into radicals, so for not factorable using integers. So leave it like that. Okay? Now, we've already done their focus. I'm going to erase what I did, even though y'all can't see this, but this is for people watching at home, which could be you if you're going back and reviewing this stuff. How do they do it? They say that 16x squared, the first one that we had up there, was 4x as an entity squared minus y times an entity squared. So that would be 4x plus y times 4x minus y, or in whichever order you want to write it. We did it. You got it right. There's a check your understanding 1 at the bottom of the page. Anyone need to see that, or are you going to do that on your own? On your own? Or you need to see it? Huh? Want to see it? On their own. Okay. Then there's another focus. Let's see if we can get there. All right. I'm putting this up. No, they're going to something else now. So I'm going to go back. They don't show this on the slide set, so I'm going to write it down for people watching at home. What if we had this? Z to the 4th minus 16. Is that factorable? How so? You tell me. You said yes it was. How do you factor that? A little louder. Z squared. That's a good first start. Z squared what? A little louder. Plus 4. Got it. Times Z squared. A little louder. Minus 4. Got it. Are we through? Why not? Because the Z squared minus 4 will go again. How about Z squared plus 4? Will that factor any further? It's a sum of two perfect squares, not a difference. So Z squared plus 4 won't go any further. So leave that alone. Z squared plus 4. But Z squared minus 4, what will that do? Z minus 2 times what? Okay, not Z squared minus 2. Z minus 2 times Z plus 2. You take the square root of Z squared, and that's Z. Okay. Does everybody see that? Perfect. Okay. Now, you probably see why I slashed my Z's, because my Z's look a lot like my 2's. And, yeah, so, yeah. So, do you see how to do that? Factor completely when you're factoring. To have your check your understanding number 2, please do that as soon as you get a chance to. All right? Now we're going to go back to review. In fact, it's so much a review, we've already done it today once. Okay? Whether you realized it or not. You want me to do this one? Okay. Been a long time. A plus B times A plus B. Can that be multiplied? Yeah, multiplied. Can it be multiplied? How can it be multiplied? Say again? A squared, did I hear?
Plus B squared.
Plus B squared. I was afraid he was going to say that. Okay? Okay? What's wrong with that picture? Besides the big gap in the middle.
Oh, the full number.
Oh, yeah.
I'm sorry.
The innards and the outers. What does that go to? Are we out of time?
No.
Oh, okay. Say again? You have plus 2AB. Okay? Remember we did that. The outer gives you plus AB. The inner gives you plus AB. Okay? So therefore you have this. Now, let me remind you what this is. This is A plus B squared. It's taking a binomial and squaring it. And here's the rule. If you don't want to FOIL it, which is fine, FOILing is fine, perfectly fine. But if you don't want to FOIL it, square the first one, A squared, twice the product of the 2 plus 2AB plus the square of the last, plus B squared. That's how you swear a binomial. Okay? And I think we are out of time. Okay? So we'll pick up there next time. Okay, you got your quiz. Be working on your quiz. If you have any questions on it, things you can't understand about it, ask me next time. Okay? If you have any you don't know how to do, I will not say, answer this question well for you. If you say, can you do number 17? Well, there is a 17. 7. I'll say, sure I can, but I'm not going to. Because that's a quiz question. But if you find anything in the book similar to it, in your practice problems, any of those things, I'll work any of those for you. Okay? So, work on those. All right. All right, good deal. Oh, okay. I only got a few people yet to take it. Okay. Very good.
Which one did I miss?
Okay. Say again? Sure. Yeah, you didn't carry it far enough, but even what you did wasn't quite right.
Okay.
Yeah. And then another thing I didn't count off for it. When you write down the quotient, then you put plus the, just like it says here, plus the remainder of the divisor. Okay, well, I didn't take off of that. All right. Can you go next door? Okay, I gave you back your quiz, right? Well, got to find it. No, you don't want the key. Okay. There is the test. You can use, next door is fine. If there's no class in there. If there is a class,
Do you have a class coming in?
Yeah, I have one coming up. What you need.
Do you want me to work on your computer?
If you want to.
I don't have anything else to do right now.
Okay. Did you have something?
Okay, for the test.
Oh, you want to see what you did. Okay. You want to sit here.
No, I'm going to have to stand up and down.
Okay.
Seriously.
Okay, I'm just showing her a test. Right at the end of the alphabet.
Seven.
12. Okay. You see, you cubed the 2, you cubed the x, but you didn't cube. You added those and you multiplied. Yeah.
I got a class.
Oh, there's a class there. Try 251. I think it's free. Down the hall, right past the restrooms and water. All right, on this side of the restroom and water. Oh, you saw it.
So I don't add the exponent. I multiply the exponent.
When you're raising them to a power, you multiply exponent. When you're multiplying, say, y cubed times y to the 4th, then you add the exponent.
Okay. All
When
right.
you're raising it, you multiply exponent.
Thank you.
Yeah. Okay. What you do with it?
Which one?
Here.
Can I X out of this?
What's that?
Can I
you can
exit
do
this?
whatever you want to. Oh, wait. Oh, let me save what I just
Yeah,
did.
that's
Sorry.
what I was asking.
Yeah, I'm sorry.
No, it's okay. That's what
I thought you
asked.
meant the computer. Okay.
No,